All right, cool. So let's get into the lesson. This is Algebra 1. If we have time today, I'll go over a little bit of the Unit 1. I sent some of them back, but make sure if you're doing your Unit 1, I might not have got to yours yet if you've done the activity. Or if not, read the comments. If you think you can do better, like if I gave you a passing score, but you think you can do better, always let me know. Usually what I do is when I grade your stuff, I put it up with a commented one. So if you look at your uploaded files, you'll see the one where I put your grade on it. So we did function. I believe we did function notations already, right? Sorry, it feels like it was a long recent weekend. Did we do function notations already? We did functions. No, we haven't yet. Okay, perfect. Oh, that's right. We did functions, not function notations. That makes sense. And in fact, I should probably look at the pacing guide because this thing actually paces pretty well, actually. I'm surprised how well this is compared to my own pacing guide. All right, so what we're going to do here is we're going to start with function notation. So we already studied what a function was. That's the idea of you have an input and you get an output. Now we're going to write how function notations are. So you guys are used to seeing functions in the way of y equals something. Well, in this unit, we're going to talk about how we call it f of x, meaning that f, this is going to be the name of the function. So we're calling the function name of function. We're calling the function f. Function. And this, what's in the parentheses, is known as our input. Now, the reason we do this is in case you have a bunch of graphs, you can't just all call it y. You need to, like, if you had a graph like this, you'd be like, oh, this is our function f of x. This is our function f. And if you're like, and here's another graph, it's like, oh, this is our function g. So that's usually how you would notate functions, because y is just whatever's on this y-axis. It's a coordinate. X is also an input. So, but if you call it f of x, you're saying the function f with an input of x. You don't know what this f is yet. Usually you identify it later, like f of x is x squared. So I'm sure they'll ease us into it. So the objective for this lesson, in this lesson, we will use function notations to describe relationships between quantities, interpret function notation accurately to solve problems. So we're going to learn how we write it down affects the relationship between two things. All right, so let's get into the introduction. So for a warm-up activity, we're saying that Anna is saving to buy souvenirs for her vacation. She already saved, so this is how much she already saved up. And she saves $2 every day. So every day she's saving $2. So first we're starting off with 25, and then we're going to add this $2 times the number of days. And this says how much money she has saved up. So for souvenirs. So I can call this f of d. So my input is d. I'm not calling it f of x because I'm saying d is my input for days. I can call it x if I want, f of x, but I would have to say 2x. And I'm not sure if we've kind of gone over it, not a lot, but you guys should be familiar with the idea of lines. Lines are at y equals mx plus b. So here's our slope, our input, and this is our beginning, our x-intercept, where we begin. So if we're graphing this, we're going to start off here at, let me put a point. I'm going to graph this point. I'm going to graph it right here because I'm starting off right there. Now, only problem is we don't have it by 1 day. We have it by 5 days. So if it's a slope of 2 per 1 day, this is the same thing as saying 10 for 5 days. So if we go up by 5, but this isn't going to help us because 10 is going to be 135. It's like, I guess it's right here. So another thing we can do is do it in a way where this is going to be a little more helpful. So if I go up by 50, it's a little more helpful. So what times 2 gives us 50? Well, if we do 25, so this gives me 50 over 25. Does that kind of make sense, guys, what I did here? I know it's a little more complicated of a way to doing it, but we don't have it as nice here. So what I want to do is I want to go up by 50. So I'm just going to say, we're going to go up by 50. Well, if I go up by 50, that's like multiplying this by 25, which I have to multiply this. You can't add. When it comes to fractions, you have to multiply because fractions are division. So in order to kind of make it a little better, you have to do the opposite, which is multiplying. So I'm multiplying the top and the bottom. So what I'm going to do here is I'm going to go up 50. So I went up 50, and I'm going to go over 25. 5, 10, 15, 20, 25. And then from here, what I can do is I can just do array. So again, if you guys have a touchpad, what you're going to want to do is you're going to click with one finger, and with the other finger in your other hand, you're going to drag it over. So you click with your finger, and with the other finger, drag it over, and then we get this little line right here. And then you can submit that, and it should say you are accurate. So this is how they're identifying it. Oh, what they did was they just plugged in 25. So they're like, hey, if you plug in 25, you know, that's really easy for you to do. So they did it a lot smarter than me. They just plugged in 25 and they're like, hey, that's 175. But the only problem with that is you had to have known that you wanted to go over by 25. If I went over by 5, it would have been a number right here in the middle, which is hard to graph. All right, so the next thing we're going to want to do, let's see what we got here. So again, guys, watch the introductions. Those videos do help you out, especially with the unit activities. When I've been looking at those, I see that some of you didn't really watch the videos all the way through. So make sure you're watching videos if they give you links. And I'll try to get to that today. So use f of x. So this is our function f of x. This just says our intercept, as we look here, there's no starting point. So that's why it starts at 0. And then we're going to go, our radius is 4 over 1. So it just says 4 because 4 divided by 1, just 4. So we're going to go up 4 over 1. This is just saying that now we're calling it f of x. So this is pronounced f of x. The value of f of x corresponds to the output. So again, we're plugging in an input of x and we're getting an output. So these functions, they're just replacing it. So this is function f. This is our first function. Function g is our second function. This is usually how they go down. They usually start off with f, then they just go down the alphabet. So they're just telling you how you can replace it and how you can basically replace your y with an f of x if you need to. This is good when you're dealing with multiple, when you're dealing with multiple functions and you need to keep track of it. If we just called these all y, it's like, well, which one's which? I don't know. So instead of writing it all down, you're like, this is function f, this is function g, this is function h. It's just an easier way to keep track of your functions. Whereas if we wrote the whole thing down, you guys can see how much room this takes up. This looks a lot more organized. And this, if you guys ever want to get into like computer science, this is how they label things. They label it usually with one letter, or they kind of give it a definition. So if you guys ever study computer science, it's really interesting. You kind of input things and you give it names, and you kind of get to remember what the computer is doing based off of that name. So this one, which of the following, which equation written in two variables is equivalent? So if this is f of x, you're going to leave it exactly the same. The only difference is this f of x turns into a y. So this is the correct answer, because all we're doing, we're not doing anything complicated. Just wherever we see f of x, it's a y. Is it making sense so far, everybody? Yes, no, maybe? Cool. All right, so this next one is saying f of what? So now our input is an x. We're saying our input is 3. So our x is 3. So instead of writing an x, we're going to write a 3. So it's h of 3. So the thing here is this wants us to answer the whole question. So what's our y? What is our h of 3? What's our y value when x is 3? So our h of 3 is asking us, so h of 3 is the same thing as saying, what is y when x is 3? So that's what's also useful about function notation, is it lets us identify what our input is right away. So in order to do this, we have to solve it. So I'm going to show my work here. So -4 times +3 is -12 minus 7. They're both negative, so I have a lot more negatives. So I have a -19. I just add these two together. So I'm going to put that as -19. And that's how we're using function notation. All right, so interpreting functions. So we're going to try to figure out what functions mean now. So here, if I were to interpret this, I'm like, oh, okay, so this tells me that my x, every time my x changes, I'm going to multiply it by about 15. So if I go over by 1, I have to multiply the x by 15. And this right here tells me my starting point, meaning that if I did not have an x, I would start off at about 12, about 13. About 13. So that's where I'm starting off right here. And then the rate of change is right here. Anything that's changing this x is going to affect it. So since it's only being multiplied, that's why it's a straight line. So let's take a look at a real life problem. So right here, we're talking about $14 per shirt. So that's why our rate of change was $14.99. This is how much it is per shirt. Every time a shirt is bought, or they're spending it, the extended family reunion. Oh, this is how much it costs. So it's going to cost that much to ship these out, and plus that much for shipping. So, and I guess the shipping is a one-time fee, it looks like, per order. Okay, so it's per order. So they're saying this graph represents how much it costs in an order, depending on our X input. So if they're ordering 19 shirts, we're asking, what is F of 19? So F of X would be this 14.99 times X, because it's per shirt. We're multiplying it times the number of shirts. And we're going to add that to 12.95. And I'm explaining all this and then realizing that Edmentum's literally going to teach it right now. So we're going to write it like this. Multiply the number of shirts by that. So that's where we get that 14x. And we're also going to do the fixed costs. So they call it the cost of fixing. We're just going to add this. It's our constant because it's not changing. It stays the same no matter what the x is. From there, what we're going to do is we're going to do f of 19. We're going to plug in 19 here. They're going to multiply that out. They're going to get that. And we find out that the order of shirts costs this much for the family reunion. All right. And what is happening here? Suppose a duffel bag. Did my question not load? All right. I'm not sure what's going on here. It looks like something's missing here. I'm just gonna solve it, and you guys can take notes. So I'm not sure what it's supposed to be. So suppose a duffel bag. They're ordering duffel bags for a team. So this is how much it costs per bag. So we're going to take this number and we're going to multiply it by the number of duffel bags. I'm just going to call it B for bag. And then they also have to pay shipping. So the shipping doesn't change. They always just pay this much shipping. So I'm going to call this F of, they want to call it X. So I'm going to erase my B and call it an X instead. So what they're going to do here is they're going to do F of 12 because they want to buy 12 bags. We're going to do 16.49 times 12. And I'm sorry for my really bad writing, guys. So I'm going to pull out my calculator. Clear this out. 3.49 times 12. And I'm going to add my 1050. So I'm going to get this 208.38. And I'll leave the work, I'll leave the work here for a second. That way, if you're watching this on YouTube, you guys can see this. Hopefully you can understand my writing. If not, you guys can always rewind and look at what the calculator said. Is everybody kind of understanding functions so far? It's pretty much what we've done before, just different writing for it. All right, so 18, it looks like this is just going to be a video. I'm not sure why my computer's taking so long on this, but you guys can watch this on your own. And it'll go through how they come up with all the questions and stuff like that. So I'm going to try to start skipping through this a little bit so you guys can get an idea of what it is. But these are really useful because they show you exactly how to use everything in the real world. So let's go to interpreting functions. So our activity for this. In this activity, we're going to be using function notation and function concepts. So if I look here, a high school band is selling homemade leather bracelets at a fair for a trip. So the group has $200 worth of supplies, which is enough to make 200 bracelets. The group is charging $2 a bracelet. So select the answer to the drop box below. So here's one thing that's important. If suppose bracelets, the profit, we want to figure out how much money they make. Well, the thing is they already spent $200, so they're already what's known as in the hole. Ask us the graph. I put the points, but I can't add a line when pressing the drawing tool, and I get the question wrong. Do you know what to do? So let's see here. To answer your question, Arthur, give me a second. Let me go back to that. That's a good. Oh, now it's loading the questions. Oh, and it was a lot easier than what I did. So it was literally just asking you to find the function notation. Um, so Arthur, are you using a Chromebook or a computer? More, I guess, more importantly, do you have a mouse or do you not have a mouse? Windows desktop. Okay. So it should be working fine. That's really weird. The only thing I can think of is you're not clicking your array. Where's my graph? I'm trying to find where I left my graph. Does anyone remember what slide the graph was on? Graph notations and functions. Oh, here it is. So let me reset this to unanswered. So first thing, you have to do your point. So you can make your points. And then what you have to do here is you have to click ray or line. So what you do here is you click where you start off, and then you want to drag your mouse over to here. So hopefully that helps. So it always tells you your instructions right here, by the way. Like for points, it says click the point. For a graph, you have to click the graph. So click and drag your mouse. If you're using a Chromebook, again, what I recommend is you push one finger down. So you go here, push one finger down on it, and with another finger, you're going to drag over to where you're going. All right. No problem. All right. So, where was I? Yeah, if you guys ever have questions, feel free to ask them in the chat. So we got that. Did this. All right. So we're doing this. So, well then. They already answered this, but B is our independent variable. We don't really know how many we're going to end up selling. How much money we make is dependent on how many bracelets we sell. So B is the number of bracelets, so that's our independent variable. Think of it this way. When you're thinking independent, think input. That's our input. It's independent, it's our input. Our Y value is our dependent. What is Y? I don't know. It depends. Depends on what? Depends on X. It depends on our independent variable. Let me do this one. So now they want us to figure out the profit. Now keep in mind the cost price. So they even did this here. How much it costs? Well, the $200 we spent isn't dependent on anything. We just spent it. So it's just that. We already spent the money. It's not going to change. So it's our constant. Our constant doesn't change, but our bracelets do. It's $2 times the number of bracelets. Remember, X is our input. It's the number of bracelets. So X is the number of bracelets. Remember, the coefficient is not the bracelets. The coefficient in this case is how much we're selling it for. So when we're doing this formula, it's 2x, because that's how much we sell it for, times the number of bracelets, which we don't know, so we put in x, minus our cost. Incorrect. Oh, they have it as f of b. So make sure you're paying attention to your input. I don't know why they called it f of x. Oh, this one they didn't call it f of x. They did call it b. That was my bad, guys. So make sure you're reading your variables. This one says b. So I'm going to say 2b minus 200. There we go. All right, and this next one is if the group sells 100 bracelets, how much money did they make? So what they're asking is f of 100. So we're going to copy our f of x, except wherever we saw an x, we're going to put a 100. So this is 2 times 100 minus 200. 2 times 100 is 200 minus 200. Well, guess what? Our f of 100 is 0. So they have to sell a lot of bracelets to make up for it. Otherwise, they're going to have to increase their price because that's a little. They have to sell half of their bracelets to make it, basically. All right. Oops. Which two statements are true? The maximum value of the range is this. The maximum value of the domain is this. The minimum value of the domain is this. So remember, the domain is our smallest number. In this case, we can't sell negative bracelets. So the smallest number in our domain has to be 0. Domain is our x value. This is our domain, all of our x's. Our range is this. Well, if we look at our range, the maximum value of our range would have to be whatever the highest we could sell. So if we look at the highest number of our domain, we can only make 200 bracelets, right? 260 bracelets. So if we look at that, that means if we sell them each for $2, the maximum we would have been able to sell them for would be the range. I don't think they give us anything else. Why would it be 320? Oh, okay. That was me being too lazy to calculate this out. So if I find the maximum number of bracelets I sell, so this is our maximum for the domain. If we subtract this by 100, so we're taking it, we're multiplying it out, this would end up being 520, take away 200. That's how we get this. So after we multiply this out, we would get 520 multiplied minus the 200. Our highest value in our range is 320. Our domain is anywhere from 0 to 260. Since 260 is not this, we can't answer that one, but we can answer our maximum. And then just let me know how you guys are finding this. This one, I probably would have rated myself bad because I was too lazy to input this number or input my maximum domain to find my maximum value. So in this case, because the line's positive, I know that my maximum domain would give me my maximum range. All right, and let's let this load. Our summary, as always, guys, before you take your test, always go back to your summary and understand what this is. So I'd like to take the rest of the time. Graph technique isn't working. I did. You said it didn't work. Make an appointment with me, Arthur. I don't know why that's not working. It should work, especially if you have a mouse. What's your browser? Are you using Chrome or are you using something else? Oops. Chrome. It should work. I don't know why it wouldn't be. Yeah, because you have to click Ray, There might be another option for a line, but what you do is you click, hold your finger on the button of your mouse, drag it over to where you go, and let go. So you want to make sure you're still holding on to it. So that's how come I said if you guys have touchpads, you can't really let go of it. So you have to use 2 fingers. If you're using a mouse, click on it. Don't let go. You're still holding on to it. You haven't let go of your button. Other than that, yeah, I don't know what else to do. Plot your points, and like I said, make an appointment with me, and I'll see if I can help you with that. All right, so let's carry on. So one thing I wanted to go over, guys, is I know I've gone over this a few times, but your activities for the unit activity, I just kind of wanted to go over this. So I'm going to show you guys how to do one of the problems, but I'm going to change it up a little bit because I don't want to show you guys the answer. Especially since this is on YouTube and I don't want other people who are taking this class later on to go like, oh, okay, I just have to do this. So I'm going to change this to -3. And I'm going to change this to 5. So mine's is going to be a little different. So, because I've noticed a lot of you are struggling here with these. So what I'm going to do is I'm going to solve this one and I'll show you guys how to do it. So when we're doing these, we're going to want to go here. And if you guys have problems multiplying, there's a video here on how to multiply using algebra tiles. It'll work, but you have to. Yeah, sometimes Edmentum's fidgety. That's right. So let's say you're multiplying tiles. You can watch this video. It'll teach you how to multiply tiles. If you need help adding and subtracting, they'll teach you how to add, subtract. But for right now, I'm going to show you guys myself since we have extra time in class. So I'm going to go here. I'm going to go to my algebra tiles. This is saying, what was my question? All right, so this is the one I made up. So this is saying, so if I wanted to show my work, I would show it like this. 5x squared, 5x. So I'm going to grab these 5x's. One, two, three, four, 5. And 3 or 5 of these. So I'm going to grab 5 of these. And then I want to subtract these out. So keep in mind, this is a negative, right? So what's going to end up happening is you have to show your own work here by saying a negative makes a positive. So this ends up being +3. So I'm going to show this down here. 1, 2, 3. And another one here. So this is a negative, positive. So that's a -3. So this is 1, 2, 3. So what happens here is these negatives and these positives kind of cancel out. So I can take these. These are going to end up canceling each other out. So these are canceling each other out. You can put them whichever way you want, but just show that they're canceling each other out. So our answer is this. So when I take my screenshot, is there a way to take a picture? Options. Well, I'm just going to take my screenshot. You guys take your screenshot however you like. Camera, phone, screenshot it however you'd like. So I'm going to take this screenshot. And when I place it over here, I'm going to say that my answer is 8x plus 2, because these are canceling each other out. I just made a nice little pattern. You guys don't have to do it, but this is showing how these canceled out. Where did these 3 come from? Well, they came from this equation. Where these 2 come from? There's what's left of that. And I could separate these out more to kind of show it a little bit more, how these are canceled. How can you turn the... Oh, you just click it. If you click it once, it turns into a negative. That's a good question. Sorry, sometimes I forget to show those smaller steps. Let me... No, where's my algebra? Where'd the tools go? Back. Okay, cool. All right. So now I'm going to show you guys how to do the multiplication. The multiplication and division are kind of similar. So the idea of multiplication, let me delete all these. You guys won't be able to do this because this is my pen that lets me do this, is multiplication. Think of it as area. And you're going to have a length. Oof. I don't know how well I can write sideways. I think that was supposed to be an H. Whatever. Well, you get the idea. And then this is our width, or it could be backwards. It doesn't matter what you call the length and what you call your width. So when you're multiplying length times width, this is your area, and this is what you're multiplying by. In other words, these are what's known as our factors. Factors are what you take to multiply. This area, I guess you can call it a divisee. I don't know. I wrote divisee on some of your guys' stuff, so I'm kind of sticking to that, but I'm sure this has a better name. You can just call it your area. So when you're doing these, I'm going to change this up a little bit. So I'm going to call this, I'm just going to call this, I'll call it negative. I'll call it negative 2x times negative 1. Make it nice and easy for me, but you'll get the idea. So I'm going to do negative 2x. So what I'm going to do, I'm going to drag these over. 1, 2, negative, negative, negative 2x. And then it's saying that I have x times negative 1 or minus 1. So I'm going to take this x, I double click it, it flips it over. And then I also have a negative 1. So I'm going to put my 1 here. I'm going to make it negative. And now I'm going to multiply. So what is x times x? Oh, that's x squared. But a negative times a positive is a negative. So I click this once. Click this once. And now I have a negative x times a negative 1. Well, that's positive. A negative times a negative is a positive. Negative times a negative is a positive. And the way you know you're doing this right is you should have this rectangle in the middle. So my answer here would be negative 2x squared plus 2x for this question that I made up. So what I would do is I would take my screenshot, I would put it in here. I'm not going to do, I guess I have enough time to do that. So take my screenshot however I want to take it. Let's say you wanted to take it by downloading this picture. So what I'm going to do is click save. I'm going to click here to open save tool. So I can take this link here and paste it. Or let's see what happens when I do this. Doesn't do a whole lot. It just takes you to the same thing you did. So you can paste your link in there if you want to do that. Click Save Tool, Control C, go in here, Control V. I can paste it in later if I want. And then I'm going to say that my answer is, I'm going to click Insert Equation. My answer is negative 2. Go over here. Gonna hit this little exponent thing right here. Hit right on my keyboard, negative 2x squared plus 2x. Or you can put a picture here if you want, but somewhere you have to write down your answer. So let's do this division one. I'm going to make this a little harder. I'm going to put 2 here. So what I'm going to do here is, since I'm dividing, this rectangle should be what I'm dividing by. So according to this, my rectangle should be 2x squared, 2y squared divided by 2y. So I'm going to grab 2y's. And then I have 2y's here. And in order to divide this out, what I'm going to do is I have to make it a perfect rectangle. Well, that's not working. I could do it this way, but this is a little harder. You want to make a perfect rectangle. So ideally, if you were starting off from scratch, you would do it this way. Okay, so here's my perfect rectangle. Now I kind of want to use lines, or I want to break this out. So what I can do is, oh, I didn't know we could use these. General tools, nope, nope. Number lines, nope. Base 10s, oh, I guess I could have done base 10s. But what I want to do here, I wanted to just draw a line. I'll draw it here, but if you guys don't have, obviously you guys won't have these. But what I'm just doing it so it's easier for you guys to see. What you do here is you're going to, oops, where's the algebra tiles? There they are. So I'm going to put y here. So if I can see here, it's perfect. Y times something. So y times what gives us this y squared? Y times y. So I move this over. I'm going to put that here. And then I'm going to move this over. Y times y gives us y squared. Y times what gives us y? Itself. Well, y times 1 gives us y. Y times 1 gives us y. So here I can see that this is what I'm dividing by. This right here is my divisor. And this is my answer. So I would take my picture, however you want to do it, and I would say, so whatever my picture is, put it here. And I would say my answer is 2y's plus 2. Did this help anybody who was like struggling with the activity? Does it make a little more sense now what we have to do? Yes, no, maybe, somebody. Cool. All right. And then the way you guys submit these, you would have to upload it. So I know you guys have to do it. Let me see if I can log into my student account one. So give me a second. This is my student account one. As you can see, I have somebody already. How did someone create this? All right. So I'm looking for, where's my algebra one? Algebra one, algebra one. There it is. So I'm going to look at all my activities. If I wanted to submit one, so unit one, I'm doing my activity. I'm going to start it up. So what I would want to do is I would want to upload file, go to wherever it is that I have the file, and download it. So since you guys are using, oops, let's see here. Oh, this one. There we go. Since you guys are using this, what I want you guys to do is you want to click, when you're done, click download. You can either download it as a PDF or a Word doc. I like Word docs, to be honest, but if you guys don't want to do that, you can always do it as a PDF. I'm fine with either one. So I'm going to download this as a Word doc. And then what I'm going to do to upload it is I am going to go back to my student account. Go back here, click this, and then I click upload file. And then when you're done, you just make sure to save it. Can I make an appointment about function notation test? Yeah, sure, Arthur. So if you guys ever need to make an appointment, the way you guys make appointments with me is go here to the appointment link, click it, and I think I still have appointments for today. So you should be fine. I have one appointment for today, Arthur, so go ahead and grab it while you still have a chance. Other than that, if you guys haven't answered the question for today, if you discovered a beautiful island where you decide to build a new society, what would be your first rule in place? And I said no stealing. Once you guys finish this, you guys are free to go. No problem. Oops, that wasn't what I wanted to close.